Hi, this is Maggie. In this video, we're going to create two classes with a composition or has-part relationship. We're going to work with the Proverb class from the video on creating a simple Java class. I'll link that here and in the description if you haven't created a class in Java yet. You'll want to know how to do that first. So we have a class called Proverb and a client program that creates an array of Proverb objects by reading proverbs from a file and sends them the get proverb messages and prints the result. I'll include a link to the video in which we created the array and file client here and in the description as well. Here's the Proverb class and class diagram. We're going to be using the Proverb class in a new Proverb Manager class, so we will only need to know its public interface, its responsibilities, and the messages we can send it to fulfill the responsibilities of the Proverb Manager class. Here's a class diagram for the Proverb Manager class. Now I've got two private fields, an array or array list of proverb objects, and an index to the current proverb. That's because this is going to be used in a game where the proverbs are presented as puzzles, one at a time, and we don't want duplicates. So they should be stored in an ordered collection, and we'll need to keep track of where we are in the collection. An array list is the better choice here so we can be flexible about the number of proverbs. There's a constructor that will take a file name and will read the proverbs in. The user of this class can shuffle all of the proverbs, and then we'll have two methods that allow the user of the class to iterate through the proverbs. Next, which will return the next proverb and then move the iterator along, and hasNext, which will return true if there are proverb objects left in the collection, or false if we've accessed the last one with next. Now I'm going to rough the class out to begin with, working in the same project folder with the Proverb class from before. So again, I'll suggest reviewing the other videos if you want to know how to create a project in Eclipse, add classes, learn where to put a text file you'll be reading, and step through the debugger. I'm going to start with field declarations, method headers, and JavaDoc, and then we'll talk about how each method will work and we'll write them. Then we'll write a quick start at a game program that will create a Proverb Manager, shuffle the proverbs, and then in a loop until the end of the proverbs, display a puzzle, which is the first part of the proverb, obtain a second part from the user, and then display both proverbs. In a multiplayer game, players guess which proverb is the actual proverb from all of the proverbs the players have written and the actual proverb. So I'll rough that out now. Okay, we have a good start now. Now I did decide to change the name of the parameter to the constructor to be filePath rather than filename, as I think it is a more general name that allows for us to read from files in any directory relative to where the program is located. Now let's fill in the code. We should begin with the constructor, which is going to create proverb objects from the text file. Fortunately, we've already written this code, so we can basically copy and paste that. In fact, I think I'll take the read proverbs method that we wrote previously and make it a private method of our class. In the constructor, we also need to set the current proverb index to 0. Now for shuffle, there is a static method in java.util.collections called shuffle. So we'll import collections and use that to shuffle our array list. That's easy. We'll also want to reset our current proverb index to 0 in that method. In next, we're going to return the proverb object that is at the current proverb index, and we'll increment the index. In hasNext, we'll check the current proverb index against the size of the array list proverbs, and if the index is greater than or equal to the size, then we'll return false, and otherwise we'll return true. So the relationship between Proverb and Proverb Manager is composition or has part, because the Proverb Manager creates the proverb objects. Now I suppose there's a possibility that another object will iterate through and collect them for itself, and that could certainly happen, but it's not how the system is going to function. The game will not hold onto the proverb objects. It will access them one at a time and then replace them as the game progresses. So the proverb objects are born and die during the lifespan of the Proverb Manager. So that is a composition relationship. They are part of the Proverb Manager. And notice that the Proverb Manager is allowing access to them only in well-defined ways. They can be accessed through the next method only, and only in a particular order. No outside object has access to the array list of proverb objects, so they can't be shuffled by an outside entity, and no outside entity could add or remove objects. No outside entity could peek at them and cheat at the game. This is a good example of the information hiding principle. Let's write our game class. This will be pretty straightforward, but I hope it will be interesting to see how that iterator pattern is used. I'm just going to write some quick code, and I'm not going to document it for the sake of keeping this short. I'll start by creating the class with a main method. I'll then create a Proverb Manager object with our proverbs.txt file as an argument to the constructor. And I'll send the Proverb Manager object the shuffle message. Okay, so now I have a shuffled set of proverbs. Now I'm going to loop through and get each proverb and allow the user to interact with them. So this is where I'll use that iterator pattern. I'll write while proverbmanager.hasNext. That will return true if we still have proverbs in the array list. And then I'll send next to get the next proverb, and that returns a proverb object. So now I can interact with that object, sending the get prompt and get proverb messages, and I can interact with the user, showing them the prompt, getting their version of the proverb, and then showing the real proverb and their version of the proverb. Let's run it. Okay, so I was just being silly there with my proverbs. We just needed some text to demonstrate the program. Notice that we iterated through all 5 proverbs, and if you remember them from before, they were in a shuffled order, not the order from the file. So we use hasNext in our test, and then next to get our next object, and we can iterate that way until hasNext returns false. That's how we can use the iterator pattern, which is one of the design patterns from the Gang of 4 book called Design Patterns. It's a very common one. There is built-in support for this pattern in both Python and Java. Let's rewrite this using an iterator object. So I'm going to create a new class called Proverb Manager Iterator, and then I'll copy and paste the Proverb Manager into that class so we can have both versions. Instead of having an integer representing the current proverb, I'll have an iterator object, and I'll have to import java.util iterator. For the iterator object, I'll parameterize it to be iterator of type proverb. In the constructor, instead of initializing the index to 0, I'll create the iterator, which looks like this.iterator equals proverbs.iterator. So notice we are calling the ArrayList method iterator, which will return an iterator over our ArrayList object proverbs. And then in our hasNext method, I'll return iterator.hasNext. And in our next method, I'll return the result of sending the next message to the iterator. In shuffle, I'll just remove where we set this.currentProverb equal to 0, and we'll create a new iterator. Let's run again, but this time creating a Proverb Manager iterator instead of a Proverb Manager. And this time I'll decline to enter proverbs. I'll just press enter. And it works the same. So you can use the built-in iterator pattern. It's always a good idea to use a tool that's already been written for you, but I wanted you to get an idea of how it's working basically under the hood, and in case you want to write your own iterator. We could write an iterator that doesn't access sequentially, depending on the class we're iterating over, so it's good to understand how they work. I hope you found this example useful. There are practice problems in the description of the video, so you can practice writing this code. I suggest you do that to solidify the concepts in your mind, and then you should also rewrite this program from scratch in Eclipse. Once you can do that, you're ready to move on.